Cool. Well, Andreas, Matt, how's it going?
It's going well. Good to see you here, Joe. Good to meet you, Andreas.
Yeah, thanks. Very good. Nice to meet you guys.
Yeah, likewise. So we figured we get a discussion going on data engineering. I think you, Andreas, you bring a very I think great perspective on data engineering, and Matt and I have our our own take on things. So wanted to get together and talk about data engineering, and I guess anything else that comes to mind. So
Yeah, I think that would be cool.
cool.
Like, um, there are so many resources out there and so many like distributed information. So I think it's cool
Hmm.
to think about a podcast where we can talk, where we can take our time and talk about this stuff.
Yeah,
That's nice.
yeah, it's awesome. I mean, so you've done I think a fantastic job. I think taking the lead, I would say, in a lot of cases right now on popularizing data engineering, at least getting out to a good audience. I mean, what got you started in all that?
Well, I've been early. That's the only thing. Like, like how long am I working on this? I think 5 years ago I started with the birth of our oldest daughter, of our oldest child. Like, I was thinking of like doing something, and I'm coming from the engineering point, and I'm from computer science, so that was what I did, and that was what I was talking about, and I just kept with it. Like, yeah. And but I think it's a cool field, especially now where everybody, or for the past years, where everybody's talking about data scientists and so on. It's a bit of
Yeah,
like,
Yeah, yeah,
yeah.
it's interesting. I mean, we almost came to it, I think, from the opposite end, where we were working as data scientists or that kind of field, and then realized it was just going to be really hard to do our jobs because the foundations weren't set up, i.e., the stuff that a data engineer would do. So
Mhm.
um, yeah, and we call ourselves recovering data scientists. I think just for that reason, because we just realized like the but at the time the role of a data engineer was still, I think we kind of implicitly knew what that was, but I don't think it had been really fleshed out because it was just, well, you need to get systems in place to to have a data lake at the time or
yeah.
whatever, and then I think it was also, there's this misnomer, this term like big data, that I think was really popular at the time, and that kind of
Yeah.
caught a lot of people's attention too, but yeah.
I think at the time in practice, a lot of data scientists were just functioning as data engineers. Like you became the guy on your team who knew how to run Hadoop jobs, who knew how to deploy Uzi jobs, for example, on a Hadoop cluster. And eventually that started to actually become a proper separate role. I mean, the role of big data engineer existed like 5, 6 years ago, but I think we started to see that it's something beyond that, especially in the cloud space, where instead of just interacting with Hadoop, you might be interacting with Spark and BigQuery and cloud storage and all these different tools together.
Yeah. Yeah. I think it's cool that now it's more separate, or it's more defined than it was
Yes.
before, right? And as you said, a lot of data scientists did engineering work, and like, and engineer or computer scientists did engineering work without naming it. Like, it was big, as a big data engineers and so on. So I think it's cool that finally it gets some definition. If data engineer is the right name, could be like, this could be discussed, but it it, it gets clearer, right?
What are your thoughts on that, though? I mean, do you think it's the right name for
I,
that job, or
what are your thoughts? Let's
I
start
don't know.
with
Let's
you.
talk about what are our definitions of data engineering, right?
Yeah.
So my personal definition is it's tool agnostic. So at the end of the day, I think a data engineer takes raw data ingredients, maybe stores them, processes them, and then makes them useful for a data scientist, a data analyst, and whoever else is consuming them downstream.
Yeah.
Yeah. To your point, Andreas, I mean, in practice, across the tech industry, data engineer can also mean someone who manages production databases for backends, in some kind of application system, which is quite a bit different than what we're talking about. We're really, sometimes you hear this term like data science engineer, which maybe that's kind of close to what we're talking about, where the role
Mm.
is really to support these machine learning, data science, and analytics roles, as opposed to managing production transactional systems.
Yeah. The thing is, like, as you said, there can also be like roles that are not that connected to data science, to the actual data science, which is also data engineering, because you need to figure out how do you process the data, how do you store the data, how do you offer it somewhere on a user interface or through an API, or make sure that it's in the right form, or what I mean. So that's something where I'm a bit struggling with the actual getting data engineering, or that data engineering is a part of data science, and like you can do it without, and you can do data engineering without data science, the actual data science. So I'm not sure about the name. It's for, as I said, for now it's okay. I made a poll for some time ago on LinkedIn, like what would be a better name. There were a lot of answers. There was no better name or something. Basically we finally agreed to, okay, let's stick with it. We're not going to find something better, right? So
It's an
but I think
interesting one.
it
Sorry, go
explains
ahead.
it good.
Yeah.
No,
Well, and I got this book the other day. 'Cause I'm doing a lot of research right now. Data Management, Book of Knowledge. Very dry, large. It's interesting though. As I thumb through the contents of this, it talks about stuff like data handling, data governance, data modeling, storage, security, integration,
cool.
warehousing, and I'm like, and big data and data science. And so they're like, a lot of this, data engineers do a lot of this stuff, but then they do a few other things, and then a data scientist, they if 80% of their job is spent cleaning data and processing data, well, I mean, that sounds a lot like what a data engineer should be doing. And so is it, a data scientist ends up doing the work of a data engineer, and then, but then, I think when I first started hearing the term data engineer, I think it was 2013 or 2014. And so it was, and this is around the time I think people were still trying to figure out what a data scientist was. This is also around the time big data was, sort of on the ascendancy of the hype cycle as a term. And so I think it was really confusing, because at the time, I think data engineer was associated a lot with machine learning, for example, right? So, but so was big data and data scientists. Like machine learning was, at least in circles I ran in, like this whole, the talk of the town. Like if you, because otherwise you would be an ETL engineer. And then that was more BI, and BI at the time was sort of like a 4-letter word. Like, you're doing BI, like, don't talk to me. We're doing machine learning. This is like a real man sport. Like, if you're doing BI, like, go play in the back. So there's, I think, a lot of elitism at the time with these types of terms.
Yeah, it's true.
But since then, it's interesting, because like data engineering has grown to encompass the BI engineer role, I think, ETL developer. Data warehousing is now in data engineering, and then data science has also grown to encompass like BI, analytics, and so it's interesting.
I think one thing that people need to understand, that like data scientist doesn't equal data scientist. Like there are these research data scientists who are working on the research and working with the algorithms and everything. Then there's more the data scientists who are applying everything, right? Or we're more going towards the machine learning engineer route. So that's I think that's where a lot of people still get confused and think, okay, when I get that data science job and I learned on Coursera, I learned all the algorithms, that I'm going to do exactly that, and like not necessarily. It depends on where you are, right?
Well, and in practice, I mean, in jobs I've had, data scientists are often just tasked with like designing some business logic. To be quite frank, like executives come to them and say, I want to pick out exactly these users who were on the site 2 weeks ago and looked at this particular type of product, or something like that. I'm not sure that that's what data scientists should be doing, but it's exactly what they get stuck doing.
Walk me through that though, Matt. I mean, you finished your PhD, you were teaching,
right,
at a university, and then what happened? I mean, you got a data science role maybe, and what were your expectations versus reality?
Well, I mean, my expectations, to be quite frank, I came into it kind of cold because I came out of teaching math, my math PhD. My PhD was on the more pure side of math, so meaning not as statistical. I did have a master's in physics, so I had that kind of statistical background. But I was expecting to kind of jump into the job and just get a lot of on-the-job training. And what I discovered is day to day, it was kind of a lot of business logic work, and then I enjoyed the data engineering part of it much more, and so I just kind of jumped headfirst into that.
That's interesting.
Yeah, turns out that's what I was good at. But yeah, the realities of data science roles, I mean, there's just been this blurring of the difference between data science, machine learning engineer, and analyst, really. I mean, it's a whole spectrum, and we don't even have good names for these roles, let alone, to your point, Andreas, data engineer and what that really is.
Yeah. Yeah, but that's also one thing what you just mentioned, that you have sometimes you have people calling themselves data scientists when they're doing more of the analyst role,
Yeah.
right? And
Yeah,
what you described before, like, tell me how did the customers have behave in these days on basically that's more of the business insight stuff. That I would say that's more of an analyst role than an actual data scientist.
Completely agree. It's kind of blurry, right? Because if you do like some kind of unsupervised clustering algorithm, then it's data science. If you impose business logic, then you're definitely drifting over into the analytics realm.
Yeah. So but that's also one thing where I feel like the data engineer has, or where the data engineer has some contact to the scientist. Like you need to understand what is the scientist actually doing, right?
Yeah. And in practice, it's things like you have data scientists who might be hacking on their laptops and they come up with a really good featurization, which, featurization can look a lot like business logic, actually, at the end of the day. And then it's like, okay, how do I scale this up? How do I scale this up to all the events that are being delivered? And then it becomes the data engineer's job to deploy that featurization in some tool.
Yeah. But you need to understand basically what like what is required here. How does that work, right? You don't need to do it. That's where the data scientist comes in. But the actual, the operational part, that's important to understand the data science part as well.
Yeah, completely agree. And I mean, again, going to definitions, I mean, Google seems to be pretty on board with this idea because their like professional data engineer exam for GCP now has a lot of questions on deep learning and data science and various machine learning techniques for exactly the reason you're talking about.
But then they also have a machine learning engineering exam too, which is, I think
a lot deeper.
Yeah, I mean, I would say it's almost a, it's a data scientist who happens to be like really good at engineering, because the types of questions on that exam are they're extremely detailed machine learning questions. Like you would have to know machine learning inside and out to pass that, I think. So,
but I think for a pure data engineer role, you don't need to know all the details of deep learning, and like, you don't need to know how to apply it or write a algorithm. That I think that's overkill. That's more if an engineer moves towards the machine learning engineer role,
right?
That's more interesting then, like, because of a lot of companies still are still stuck on the simple stuff, like, right? So for the engineering,
what's the simple stuff you're thinking of too? Like when you mention simple stuff, what are some of the things that you're seeing?
Well, for me, the simple stuff is running ETL pipelines, creating APIs, figuring out the right, or using data warehouses to send the data in so an analyst can look at it. Like nothing that includes or stuff that doesn't really include machine learning and automating that. Like the stuff where you don't need algorithms for.
Right.
I think that's a lot of companies can actually benefit from this. They don't need to have per se a data science.
Well, and furthermore,
team.
It's also a prerequisite. The stuff you're talking about is a prerequisite to get to data science.
To more or less to automate it, I think, or to productionalize. If you think about like getting a data scientist and you have some stuff in CSV files laying around because they have been recorded somewhere on I'm coming from the IoT world, so from some machine, you write a log and everything's there and you get the files. Then you can't do it without it, like start up without it. But that's not the goal, right? You want to create a product out of it.
Yeah, yeah. But you sometimes do see people making pipelines for their own sake, which I think is kind of funny. But yeah, I'd like to get your take on this too. I mean, how often do you see people just spinning up architecture for the hell of it and not really like having an end goal?
I think the most of the time you see people spinning up stuff, especially now with the cloud platform where it's so easy.
It's so
right?
easy.
Spinning up stuff quickly to, okay, I have that idea. I could use that. I could create a dashboard and like create a small database behind it, and I spin it up and run it, and that's one thing. And then they go to the next one and the next one and the next one, and then you have this. And some data scientists love to do that. And then you have these tools, and how should we make this? How should we operate this? Like, how should we integrate that? And that's most of the time where I feel people struggle to actually think about the big picture. Like, does that fit in the whole platform?
That's a good point. How do you communicate that big picture to people, or how do you help them understand that? Because I think that's a huge missing piece.
I think the only way is if you have a project. I'm always coming from the like, you're building a project, you're
Yeah.
right, or you have a startup. Let's say you have a startup. The goals need to be pretty good defined of actually what do we want to deliver to the customer, what do we want to deliver to in-house analytics, right? Because these are usually the two use cases. You have something that drives the business, something for business analytics.
Mm-hmm.
And if these two are well defined and you know basically in which boundaries they have to work, then you can start communicating this and start people. But sometimes you have to like elbow people to don't do that. We cannot operate it, right?
And what you said about goals totally resonates. I think that's one of the enduring problems in data science right now. It's just a lack of goals. Like, what are we actually trying to accomplish? I have one friend who was working at a company, and he was hired as a data engineer. And so he gets this job, and he's like, okay, what am I supposed to do here? And he's like, well, the executives basically told him, we are a startup, and so we want to be able to go tell our investors that we have data. So just get some data. I don't know.
I've made pitch decks with the same thing. I think it caused maybe 1 or 2 point multiple in the pitch deck because we were raising money for all the AI.
Yeah. Calling it AI. There is this. How is that meme that goes around like, or that you call it AI when you want to get funding? You know which one I mean, right?
Yeah.
I can't,
Yep. Yeah,
can't
and
remember.
I think I've seen the meme and I've definitely lived it a few times. So, because I know it's I think it's harder right now if you slap AI into a product for your startup. I think it's harder just because it's become kind of beaten. But several years ago, this was like the way. If you wanted to make a lot of money real quick from like investors or like just people with a lot of money who just really want to get rid of their money, put AI on something. It could be anything, right? It could be an actual company, could not be an actual company, could be like a candy bar, like anything. If it has AI on it, you'd raise a lot for sure.
I think it only makes sense if the AI part, the machine learning part, or whatever you want to call it, that's the main, the central point, the central technique that you use. If it's just like some side product or some side project, that's not going to work out. It's just for the slides.
Uh-huh.
Right?
Yeah, and
And
it's
that's how we do
interesting.
things in America, right? Have
That's
really ridiculous pitch decks.
no, that's also how you do it in big companies. Like
Yeah,
if you're in a huge corporation and you want to move something, you need to have some good slides with some big names on it, like or big terms like AI and so on, and then you
blockchain.
might get funding, right?
Yeah. Like I remember the days when I got into machine learning. I remember when AI was still. I remember in one of the first pitch decks that we were making, we actually avoided saying the term AI because it was still coming off of the
Yeah.
AI winter, and people were just very skeptical of it. So you'd call it like predictive analytics or machine learning. You might put that in, but people like predictive was still like the word you would use because people were like, I don't know what machine learning is. It sounds weird. Um, and then I think around like 2014 or something, that's when deep learning came into vogue because you had and then AI just all of a sudden you see it everywhere, and so. But it's funny because now I see like techniques, even linear regression. I've seen that like labeled as AI, which is pretty hilarious. And then like forecasting techniques that have been around for like 50 to 100 years. Now that's AI all of a sudden because
Yeah.
and
But I remember I remember we had it's also a time ago, some time ago, where we also had these discussions. Don't put AI on it. Like
right.
let's call it let's call it predictive this, or
Mm-hmm.
we're doing anomaly detection here. And like these where because AI is so a lot of people think about AI about robots and like
Right.
it's really clever and it's like it's a very big term. So
Mm-hmm.
yeah,
Well, it's still a big field. I mean, like true AI is,
huge.
I mean, that's a fascinating field, but yeah, machine learning is like a part of a really big
Yeah,
subject matter, and deep learning is a subset of machine learning. So it's kind of like keep rolling it backwards, and yeah, and that's interesting. And I think it's interesting too because it's influenced a new generation of data professionals. So I think when we are all probably working in data, it was just a much different, I'd say, planet than the one we're inhabiting right now in the data world. So, yeah.
I think that sorry. I have the feeling I can't keep going and going, and Matt doesn't cannot say something because I always talk. Like,
Oh, I interrupt too. Don't worry. I'm quite good at it.
uh,
I'm curious. I'd like to ask you this. So, like,
yeah.
in my view, there's been a dramatic evolution of the data engineering role, whatever that is, in the last like 5 to 6 years. What's your take, Andreas, on what's happened in this space in the last 5 or 6 years?
Well, and my take is that a lot of stuff. When you think 5 6 years back, people were a lot of more focused on stuff like Hadoop and so on, and the
Yes.
cloud platforms were coming up, but like it was still limited in the analytics part, right? But what has happened in the last few years is so crazy. Like there, it that's the big change. Like you have to know at least one cloud platform nowadays. In my opinion,
Mm-hmm.
you cannot go anymore with and think about stuff just installations of something that like
Right.
on premises or some stuff that doesn't work. You need to know AWS or Azure or GCP, whatever is important in the area you want to live or you work. Right.
Yeah. Yeah. Completely agree. And my other take, and this is a bit self-serving, frankly, because I've done a lot of work with orchestration, but it seems like the problem of orchestration has started to become much more important, maybe even on par with some of the data processing itself, because you're in the cloud. And instead of just being on a Hadoop cluster with some simple Uzi scheduling, you might be scheduling, 10 different systems on a cloud platform to make up your whole data pipeline, which could include, some kind of automated machine learning product. It might include something SQL based. It might include Spark, probably some data ingestion from an API. And so data engineers are becoming sort of these, ringmasters in the circus, having to keep all this stuff running with a much bigger operational component than maybe they used to have. Or at least in the old
That's
days, the operations were like Hadoop ops versus cloud ops with a lot of different systems to keep running.
That's true, and that's also the point that fits to where what we talked about earlier, like the goals, because it's so important to actually have the goals. What do you want to build? What do you want to run? Because the I'm coming more from the architecture side. I love doing architecture. I love thinking about,
It's
okay,
fun.
which tool could we use here and there, and how could we model the data to fit into this, and or which one do we use then? Like when you think about the whole platform, it's super important, so that you cannot build everything and you cannot operate everything. You cannot have 100 tools in there. You need to actually focus and have a goal where you want to go, and that's one of the super important things. And that's one of the problems that's come up now in the past years. Like the variety is so high. It's
It's so high. Yeah, I'd like your take on that too. I mean, with the role of a data engineer becoming less and less, maybe being a Hadoop expert, for example. I mean, what do you guys think are the skills a data engineer needs to have, today and maybe for the next few years?
I think to me, it's like foundations, first of all. And foundations are going to be things like really strong cloud skills, probably really strong SQL skills. I consider that kind of a baseline. And unfortunately, I find a lot of data engineers kind of lack the SQL skills actually. Really strong Python, and then probably a sense of the ecosystem and understanding of what tools are out there, so that, to Andreas's point, they can choose the right tool for the architecture instead of just doing it helter skelter. And then the ability to learn. I want my data engineers to be able to pick up tools. If they decide that Apache Beam is the right tool, then they should really be able to go get really good at Apache Beam. If they decide that Spark is the right tool for the job, then they should have the ability to pick up Apache Spark. I think there are common data paradigms that extend across data tools. If you understand how data works, then you should be able to pick up these tools in detail within a reasonable amount of time and become a good engineer on a specific tool.
that's yeah, that's true. Like you need a good foundation. When I was thinking about, okay, what do you need from what do a data engineer need from a foundational standpoint, where I have in my academy I have a course about that, in the but like I thought, okay, what is for from my experience, and I have to agree, SQL is one of the most important things. Like not just querying data, but actually being able to, okay, let's design a database. What does that mean? How do you do that? How do you build something like that? Because you most likely you need to work with it, but most likely you're getting something that might not be optimal, or something that is already in operations. Python as well, like Python, yeah, that's the thing. Few years ago it was Java, still Java in my opinion, especially on the Hadoop world, it was big. But yeah, Python is, you cannot go without Python right now. About the ecosystem, yes. I don't want to go further into that. I think though one point that is important, or one topic, is actually like is computer networking. Understanding
Yes.
how do firewalls work, what are ports, IP addresses, subnets, uh, DNS servers, and so on. Because when you build the whole thing, at some point you're getting to that level on, okay, now I need to create private or public subnets, I need to give addresses, I need to, like, if you're on AWS, you're running into these things, and if you don't have some foundational stuff on that, that's problematic, right?
Yeah. Yeah.
That's
Cloud has really changed that, right? On the one hand, it's made networking a lot easier. There are a lot of topological details about networks that I don't have to worry about on AWS or GCP. But yeah, it means that what used to be a network engineer's responsibility frequently now becomes a data engineer's responsibility,
yeah.
which is one of the reasons we are so ardent about advocating for certification, because that's one of the best ways to learn that stuff. I don't know where else most data engineers are going to learn networking if they don't certify.
Or if they're not forced to learn it, right? I mean, you
Yeah,
would,
yeah, you got to be
yeah.
forced.
I
You
mean,
got to force
you would
yourself
have
to
to
do
have.
it.
I mean, there's a lot of good resources, I think, but I think it's also, I would say, learning the fundamentals of networking, which I think is separate from how AWS wants you to do networking. But I think to what you're trying to say, Matt, though, is also there's certain ways that clouds want you to do stuff. Like if you approach networking on GCP versus AWS, you might be in for an interesting time. There's some things that are similar. There are some things that are very different.
Mm.
Google has a global network, for example, so it's fundamentally structured different than the way AWS does stuff, and like, but you need to know those nuances when you're trying to do. But you also got to know how
basics, right?
Yeah, basics. But you also got to know how networks work. Period. Like irrespective of a cloud, right? So I think I tend to take a balance between you two, where I think certifications are important, but like you'll know what you need to know to work in a cloud. But that's no substitute, I think, for spending the time to learn the basics outside of a certification. Like you're not going to learn SQL in a cloud certification, for example, right? But you should still learn that, just like you should learn the fundamentals of probably a lot of other stuff, frankly, like how do distributed systems work, right? Like I think a cloud cert will teach you how they do distributed systems, but that's no substitute for learning how distributed systems really work under the hood. But that's even becoming obfuscated, though, right? So it's interesting, just the number of tools. I mean, I'm talking to new companies like on a daily basis in the data engineering space because they want to work with us, or maybe just interested in seeing their product. And what I find fascinating is just the level of abstraction occurring in the data engineering tooling space right now. So I talked to a company the other day, Upsolver. We're going to be working with them pretty soon, but they basically are like a data lakehouse, but without Spark. So they just took all the best things of Databricks and then got rid of all the stuff that people didn't want to deal with, which was setting up, dealing with infrastructure or clusters, Spark clusters, or that kind of stuff. Now it's just set up your destinations, set up your sources, set up your destinations and start querying. That's it.
Mm.
And it'll be interesting to see just the evolution of what a data engineer does, I think, in the context of a lot of these like lightweight tools that are just meant to, basically just perform a job. Because they're one of like hundreds of companies in the data space right now that are all vying for attention. The same day I had a call with a company from France. They're doing like AutoML. But when I looked under the hood, I was like, you guys are actually acting as a data warehouse for your data as well. So you pretty much have end to end. If a customer buys your product, like there's nothing really for a data engineer to do at all, except maybe model data. So
yeah, it depends. I don't have the track record of like actually proving this, but it feels to me like most of the time the advertising is very, very good, and it looks like very simple if you do simple stuff. But
right.
the more complicated it gets, then you're getting to the details where it's not a simple click pipeline that everyone can do. Like,
yeah, codeless doesn't exist as far as I'm concerned.
Yeah, same.
For a simple level maybe, but for in the real world, I'm not sure. But I want to get back to the abstraction point. I think you see this everywhere when you look into, for instance, into Spark. When I started out, you had to use Scala and you had to use RDDs, and you were working. Okay, you were thinking, okay, now I need to look out that stuff doesn't run on the driver, and how do I need to build it that stuff runs on the executors and everything. And now you're just like using a data frame and you process that, and everything is done behind in the background, like poof. Like as if the parallel processing or the distributed processing wasn't there. Like
right.
That's a lot.
I remember the same thing too. Because like when you, I mean, I think we probably are. I'm guessing we probably started in Spark around the same time, which is like the first generation of it, right? And so you would approach it kind of how you did in the Hadoop days, where you're like, okay, so I need to think in terms of like mapping and reducing a problem, because you didn't have the context, you didn't have data frames back then, so you had to think about it in terms of, okay, so I'm gonna get my data. And yeah, the level of abstraction there, like MapReduce, I think was, I don't know anybody doing MapReduce at this point. It would be, or even using RDDs, you have to have like a really special case to really want to explore that aspect of Spark now. I mean, it's still there. Knock yourself out if you really want to go that way. Like, nobody's stopping you. But when you look at the types of problems that people would solve with Spark, I mean, they would typically be tabular problems, right? Rows and columns. And
Very often,
then
yeah.
I just need to do aggregations. I mean, that sounds a lot like what I would do in a data warehouse, for example. Or it might sound a lot like something I would use maybe SQL with, or maybe if I'm using a data frame, something similar to what I would have done in Pandas. And now, I think to your point, what was, I think, a non-trivial way of doing stuff in Spark is now like insanely easy.
Yeah,
So easy.
super.
Yeah.
I think there is this issue in data engineering. There's sort of this macho attitude.
Yeah.
I have a friend who worked at Google kind of, maybe, I don't know, 2010 or something. They're still doing MapReduce. And he said that they were writing MapReduce jobs in like C and C++, which sounds horrible, doing text processing in C and C++ at that level. Um, but I think a lot of people are kind of wistful for those days. Like they really just want to spend a lot of time hacking on code when really the tools make that easier now. And you really should just be focusing on the data and using,
Yeah,
for example, Spark the way it's intended to be used in 2021.
yeah,
Mhm.
I think so as well. It's
Yeah.
for me, it was always a bit annoying when it should be super simple. Like I just want to take that data and I want to, while it's streaming in, and I want to aggregate some values, and that's it. Like how complicated can it be? And then you and then you have to build some annoying thing. Uh, yeah.
Like
Mm-hmm.
often it's just parsing, right? Like what were people using Hadoop for? Well, often it was just like parsing logs. That was it. It was this
Yeah.
really, really hard problem at the time.
Yeah.
I think with working with logs is still not that trivial.
No,
But
no, not at all.
there are tools that can really help. Like I had a coaching student where we talked about, like he's like, okay, man, I need to look I need to look into the logs, and I spent yesterday 5 hours looking through logs, and like we said, oh man, that's so. If that happens, does that happen often? Sometimes. And like he's not getting any, he wasn't getting any like metrics out of it. So I said, okay, let's use something like Elasticsearch, where
Right.
you don't write the logs into a file. You log that in Elasticsearch, and you build a Kibana dashboard, and you visualize it. And so these tools can help, and but it's still with the whole logging, it's not trivial. It's
Mm-hmm.
And I think part of what we advocate for too, I think there's often a lack of communication between analytics data engineers and software developers. And so the software developers just structure their data any old way, and they just kind of dump the logs, and they don't really think about how that's going to be processed downstream. And I think some of this work can be reduced by changing the structure of the logs just with more communication, saying, hey, look, we as the data engineers are consuming these logs consistently. Can we like kind of restructure them so that we're getting the analytics we need? Or even just take the specific entries you need and then dump them into Kafka or PubSub and structure them in a nice JSON format. So we're seeing exactly the data that's going to feed our data science models downstream.
yeah, in a hopefully that's possible. What I have learned in in the past, that if you're working with like with departments who are running systems for a long time, and they're writing stuff in a certain way,
Yeah.
you're it's not easy to like, okay, now integrate, please integrate exactly how we want it. It's like, no. So you need to, sometimes you need to take what you get, and yeah,
It's political, to be sure.
sometimes it's political, but also it's a time problem. Like
Yeah, that's
people
fair.
can't spend the time of integrating, or yeah,
But I
of
think what
doing
we're going to
exactly
start
what you
seeing,
said.
though, is, I mean, my prediction is the roles of data engineer and software engineer, I think, are going to start, um, they're going to start combining. Because I think as applications become more data centric, um, and as I think the role of a data engineer, I think it's to so what I see happening is, to the extent that there's a lot more abstraction going on in the ecosystem with tools, the data engineer is going to focus more on like engineering problems in combination probably with more source systems, because that tends to be where I think a lot of the headaches are, in terms of data quality perhaps, or just a variety of problems, as well as having the ability to just like bolt on, whatever abstraction layer that isn't like completely value add to the company, like connecting data sources, for example, right? I mean, that's very much a solved problem if you have, if you're using like Fivetran, for example. Like if it's not something that's like very unique to your company, if you're just hooking up a relational database to Snowflake, for example, like that's solved by like dozens of companies at this point, right? Like you shouldn't have to rewrite that part. But what you might want to do is work with the software engineers on the data that's in MySQL, and maybe figure out a way to make that more useful downstream. Because I think that tends to be, because otherwise you're trying to solve the problem after the fact instead of just dealing with it as it's created. And so predict things like master data management. That's actually stuff like that's going to come back into vogue at a smaller scale for smaller companies, and treating data quality issues at the source, because that tends to be like the biggest headache. So anyway, maybe I'm right, maybe I'm wrong, who knows. But
I always feel like with all this data governance and like I said, how's it called, master data management, a lot of companies and a lot of let's say companies, a lot of companies are still not there. They're below this. They still work in silos, though, so they have their analytics platform, and that might as you said, connect to some databases using some connectors, but it's not like it's super integrated and so on.
Mm-hmm. Well, it's hard too. I mean, there aren't a lot of good offerings in the data governance space. I think it's going to come into vogue. It is starting to, but yeah, for the longest time, because like I mean, when you mention data governance, people are just like, can you just go away? Like, I don't want to talk about this. This is boring. And it would be like if somebody just kept preaching to you about like flossing your teeth all the time. You're like, dude, can you just like, can we talk about something else? Like the most useless topic. But then you're finding out it's actually really important. But to your point, I think right now it's like trying to implement these types of processes and systems. Nobody wants to do it, and the tooling out there is not that, it's expensive if you're going to go down this route. Like this is typically stuff that's reserved for like very big companies. But as data becomes more front and center for everybody, I think this is going to you're going to see some pretty interesting approaches. So
I think it's the maturity cycle that you've talked about, Joe. I think when big data came on the scene and everyone was talking about data lakes, they started dumping all this data into their Hadoop clusters. And then at some point, as they matured, they realized that it wasn't the data that was important. It was the schemas and the metadata and knowing where that data came from and being able to evolve it and update it and all these other things that are just kind of banal in the relational database world that now they needed to do on data lakes. And I think we're moving toward a greater level of maturity where these cool tech companies are also realizing that they need data governance and they need data management and all these things that they viewed as just stodgy corporate BS in the past.
Yeah, that's true.
Yeah, but it's going to be a marketing issue too. I mean, because like we all sort of have an aversion. I can just tell by body language. If we talk about data governance, like, ugh, this is icky. I want to go somewhere else. So, it's like talking about hemorrhoids, you know,
or like GDPR and this stuff.
Right. So. But yeah, I don't know. I mean, but that's the evolution that I'm seeing, though. At least, kind of reading between the lines and sort of, pushing out is that, all these like topics. I think, because it is a maturity cycle, and all these topics that people just put to the side because it's not the cool stuff to talk about or do. Like now, well, because everyone talks about it, like, oh, this is a huge problem, right? It's kind of like global warming. It's like, oh yeah, it's a big problem. We'll deal with that later. Like, look, we have other things to deal with. Like, and so, but now that the tool, I think that because of the layers of abstraction, it's becoming a question. Okay, so like, if pipelines are a solved problem, for the most part, right? There's obviously some pipelines that need to be customized, but if 80%, 90% of the problems are just solved by off-the-shelf tools,
Mm-hmm.
then the role of any data person changes. The same thing's happening in data science right now. Like I make a pretty good argument that, 2016, like making models was still like the thing to be talking about. Today, I don't think you should be talking about making models, training models. It's very much a solved problem for a lot of companies, because you just have frameworks that can do this, that can solve this problem for you pretty easily. So,
But it depends on what's your use case.
mm-hmm.
Like for some use cases, of course, there is everything already done. Like you just go in there, get yourself the right library, and feed it your data, and that's it.
Mm-hmm.
But for like special use cases that there may not be that popular,
Right.
especially something that has to do with some actual like hardware,
Yep.
uh, then it's a lot of work, and you need also a lot of domain knowledge to actually
Yep.
figure that out, right?
Yeah, and I think that's where I think everything's heading, right? It's instead of like a lot of the ceremony that went into like dealing with every single tool. Like we talked about Spark and RDDs, and the fact just to get Spark working, you had to know Scala and be good with RDDs. Like that's gone. Those days are behind us, right?
Yeah.
Now, if you have a special use case, I think to your point, I think what we're saying is like focus on what's your competitive advantages as a company, your core competencies, your special use cases, and like go all in trying to solve that as well as you can.
And build exactly, and look what you build, or figure out what you're building from a platform standpoint.
Yep.
Because now with the, I'm not sure, did I say this before? No, it doesn't matter. Like we have so much variety in the tools. People tend to go and I could use Spark for this, I could use Snowflake for this, I could use this for that, and then they start going, okay, let's go, let's do it, because it's so easy to set up and so easy to start. But actually you should look into, maybe sometimes it's good to actually think about, how would that in a relational database work, to actually figure out, okay, where are the actual problems there,
Mm-hmm.
instead of strictly immediately going to some NoSQL or whatever, right?
Mm-hmm.
And I think that's a huge problem right now. People, I also see that in my coaching sessions, where I get students, and we start usually by, okay, let's figure out the data set, let's figure out some goals for that data set, and they tend to already start to, okay, I could use, then let's start processing this with that and with that, where I have to actually like pump the brakes. Let's just figure out, okay, what is the data, how does the data look, what do we want to achieve, and now let's build everything in between purposely for this goal, and not like just use stuff. And I think that's a big problem right now.
It's a big problem. I mean, how do you advise your students to, and other people, I guess, to think about filtering out the marketing messages, right, of a lot of these tools and products?
You mean by what you're using, what you're about to use. If you select the tool, go to the documentation. Forget everything. The documentation is the one thing you need to go, in my opinion. It's like the website and the marketing, that's good to give like an overview. Okay, what does that thing supposed to do? What is that supposed to do? But usually I tend to send everyone go straight into the documentation, find out how the data is structured there, how is it distributed, how can you access it, what tools do fit to these, and then you get somewhere. Like,
I'll add to that. I mean, the social capital part to tools, like you need to find out how other people are actually using it. I mean, maybe it's a terrible tool in spite of what the documentation says. And ideally, you can find out, okay, is this a good tool? Is it a bad tool? How has it succeeded for you? What are your key challenges? There are a lot of really great Slack communities around tools now that help with this, and just connecting on LinkedIn and talking to people.
That's also true. Yeah, that's true. That's also a good point. That's a really good point.
Yeah,
and trying it out, of course. Then
trying it out.
Yes,
it's a big one.
Just make a simple proof of concept and like.
Yeah, I mean, the other day, I mean, we saw somebody. This is interesting. I mean, they were their analysts had spun up a Snowflake, and was using Looker, and I'm like, yeah, that works. Go for it. You know, for the use case. And at the same time, the engineering team was like, oh yeah, well, let's spin up a Athena and
Yes.
and another BI tool. And we're just like no, I don't
Perfect.
know.
That's exactly what you don't want to do.
Right. Like you haven't even gotten the first one working, and which will accomplish everything you want to do with the other one that you're building now. So we're just like, just time out. Let's have a talk.
Yeah.
So yeah, what's up?
But that's
Oh,
that's also a part of responsibility, right? Who is responsible for the platform?
That's a big piece.
That's a big piece. You cannot let everyone do what he wants on the platform.
Right.
There needs to be someone in charge of the actual architecture, and that the exploration or that where this is going is coordinated again with your business use case. Otherwise,
Yeah, cloud is
exactly
almost
what you
too
said.
easy, right? So many things are turnkey. And so if I'm a developer and I've been on AWS, I can just turn something on. And like
Yeah.
you were saying earlier, you can end up with, 20 different tools to do what should be just one tool.
But then they don't do what you said, Andreas, right? They don't. The people spinning this up, they don't read the documentation. So it's like,
Yep.
oh, like Redshift sounds kind of cool. Like we can use that for a transactional data warehouse. Like let's just use that. Um, I've seen this happen, and so not taking the time to figure out. Okay, so like, what is this tool supposed to do, and like, how does it want to be treated, and like, where does it fit into our stack? Instead, it's like, shit, you can do analytics on that, so we'll do that, and then we'll actually just use that for our regular data store. And it's like, what the?
How many engagements, Joe, have we seen these problems where someone is using a columnar data warehouse, specifically columnar, because that's where you're really, really going to have problems, and they try to like do continuous updates on it?
Often, too often. Yeah, I think it's just a matter of people try and apply what they know to a new tool and expect it to behave the same way. So, like it just got rows and columns, right? So why is that any different than the relational database I'm using? Should be the same. No
We
different.
sometimes call the curse of familiarity. It's like, oh, it's still SQL, so therefore it must behave the same way as my Postgres database.
behaves the same way.
Yeah.
Yeah.
That's interesting though, and again, I think what you're going to find is the more fascinating one I think is with streaming technologies becoming more into vogue like that. If people are getting batch, I think if they're having confusion about batch, streaming is going to kick that up a couple notches. So
I think for me, always streaming is one of the fun parts and the important parts. Like,
interesting.
Because some running some batch jobs, and you need that sometimes. Of course, if you have a data source where you then once a day get a log file, right, where we're talking about earlier, then you run a bulk import job and that's it. Like, okay. But the actual fun part is, okay, when you say, now I have APIs and the data is flowing in constantly, let's build some really nice pipelines they're taking care of like some pre-processing, putting data in different, like in a data warehouse and in a transactional database, and like have everything in a streaming manner. And that's what I find really interesting. And yeah.
What's your choice tool for streaming? Are you a Spark streaming advocate plus maybe Kafka, or what are your go-tos on this?
It depends on, for me, it depends on which platform you're running. Like and also like it gets down to the details. Like, of course, if you're running a Hadoop platform, then you most likely use Kafka and Spark, right? That's installed. That's what it's there. That's the most common stuff. But also, if you're running on AWS, usually I'm a big AWS guy, so I'm more into the AWS terminology. So usually, what you do is you run Kinesis and you run a Lambda. Sometimes Lambda is absolutely enough. You don't need to run a Spark job on it, right? But when you think about, okay, now you could have some larger messages where Kinesis is capped at 1 megabyte per message. If you have larger messages, okay, then you need to figure out, okay, then let's go back to a Kafka installation or something, right? So, but I would say first use what is already there.
Yeah.
Yes.
Go start by going serverless, build this up, and when you, except if you already see it coming that you have these problems, right?
Right.
But that's the way of actually building something fast and building something
Well, frequently this solution, I mean, depending on the data volumes of the stream, it might work just fine forever with almost no operational overhead. I mean, you always want to be looking ahead to say, okay, how much is this going to cost me using Lambdas? Do a quick estimate. And when is this finally going to break? Like, at what point is my solution going to get overwhelmed? And then start looking down the road. If it's next month, then maybe you should start with something else. If it's 5 years from now, then just build the simple turnkey solution.
Well, yeah, I mean, even a solution that we developed for one of our clients, it was a event processing system, and I think using Lambda and Kinesis, it ends up costing like $20 a year at their expected volumes.
Yeah.
It's like it costs more for me to write it than it does to run it. So, but I think the temptation was, do we just use like a streaming platform like Kafka? I'm like, I definitely don't do that yet. That would be overkill for what you're trying to do. But it's interesting too, because in GCP, I know like Spotify, they're a big GCP user, and I think they did a test of PubSub, and it out of the gate, it did everything they needed. They didn't need to do anything more. And that was like 2 or 4 million messages a second or something crazy. And it just worked. Done. So.
Yeah, if it works and if the price is good, sometimes you run into these problems where you have these, where it's cheaper to actually I don't think for the pricing. It depends on, we would need to have a look into the pricing exactly. Like when you compare Kafka to Kinesis, just as an example, this might not 100% fit, but with Kinesis you're basically paying how many messages are you sending through, right? So that's a factor that drives the prices up. If you run something like a Kafka cluster, you're paying for the EC2 instances or the Docker containers, and that's it, no matter what you're doing with it. The same if you run if you set up a Hadoop platform on AWS, you just use it as infrastructure, then you're not paying, or Databricks, like you're not paying for the actual data that is getting processed. So sometimes it's a calculation example, like what to use.
Yeah.
Because
if you had a line of like a fixed cost here, like what's the fixed cost, and then like at some point serverless, especially if you happen to be really successful, it's going to cost you more money than just paying for it. So
I'll just add, I mean, I think if you're a modern data engineer or cloud engineer, I think most of us, when we came up in the world, we're taught about performance optimization and performance engineering. But I think we need to shift our mindset to think about cost engineering, like from the get-go, not necessarily think about performance so much as like, how much is it going to cost per message? And then let's compare to Kafka. Once I have most messages, it's time to cut over to a different solution.
That's a good point. Yeah. Because most of the times you cannot even tune the serverless stuff, right? It's out of the box. You can't say, okay, how many shards do I want? But there's no performance tuning or something like before, where you go into the details and the configuration and
The reality is that cost models are not reflective of resource consumption on the back end for these cloud providers. Like, all of them ingest data for free because it's all about vendor lock-in. And your goal as an engineer is to sort of game the system. Like, how can you figure out how to be as cost effective as possible, given the cost constraints they put on you?
They that's the business model. When you look at every stupid thing costs something. Like, okay, you want to secure your platform, use our key store, and every time that key store is queried, you're paying for every query, just a small fraction of a cent, but that ramps up, right? And so they do it very, very clever, and like, you have the benefit of not taking enough not needing to care about it, but it's going to cost you something. That's
and it's good to identify ahead of time where things could go wrong. I think that's a mistake people frequently make. They think about, okay, this is roughly what I think I'm going to use. It's like, okay, but what if you get a lot of traffic one day? Well, what's that going to do to your cost numbers? Like, what if your site blows up? What's that going to, going to do to your Lambda costs.
But we had
Start
one
looking down the
client.
road.
We had one client
Yeah.
that was using a, uh, a certain pay-as-you-go data warehouse, and ended up, I think, incurring about a 1/4 of their annual expected consumption in a matter of like a week.
Okay.
So that was very.
Uh,
We're helping them get through that now, but
but
just because they didn't understand the. Uh, Again, it was not understanding how this particular tool needed to be used, and instead having their own opinion about, oh well, if we just do it this way, it'll be just fine. And then many tens of thousands of dollars later.
and then you're in there, then you have a problem because every day you let it run, it's going to cost you a lot. So you need a
Yes.
solution quick, right?
Yeah,
So
yeah, that happened. But that's not uncommon though, right? Because I think people are eager just to jump in and start using the tool and not taking the time to understand the way it needs to be treated, as well as the cost implications of it, and understanding cost modeling. That I think Matt's right. The cost modeling is like one of the more underrated skills, probably of a modern data engineer, especially. Like that's, yeah, I think.
it's hard with the cloud
Yeah.
platforms because there are so many hidden costs. Like it's all in plain sight. I mean, it's not hidden from you. If you know where to look, you're going to find it. But like, it's hard to actually calculate. Okay, how long are these lambdas going to run? How much does that cost me? Like, it's sometimes it's not that easy to come to a number for everything. Like,
How do you with your academy, and I guess with your clients, like how do you coach them on concepts of uh, best like cloud best practices?
I I always try to do this like a hands-on thing.
Hmm.
The my push is always we're doing a project and we're doing that project on the cloud platform. I can advise you on all the other platforms. I'm not an expert, but I can show you where to look. And I think that's actually to gain some knowledge and to gain some hands-on. That's the most important thing. Um, and I think it worked out until now. It worked out really good. Also, like when you think about the cost stuff, this is going to if a student is using AWS, that comes up very quick. Can I do something wrong? What do I need to take care of? Okay, then let's think about this. Let's calculate this. Let's think about how would it look when you scale it, right? So
Even with we teach a SQL class, an advanced SQL class for analysts at the University of Utah, and we have them use BigQuery. The first thing we drill into them is like, before you run the query, look at how much data is scanned, and then in your head calculate how much it's going to cost you to run that query. There are, for the most part, they're probably not going to get into trouble, but there are some of those
yeah,
public data sets that are a couple terabytes, and so you could spend a couple bucks just in one query. And if you did that repeatedly, then you could spend a lot of money.
you can spend money, yeah. Yeah, I think for most of the, and I have this discussion with my students a lot, like for learning, but do I really need these huge data sets to actually learn that?
Yeah.
Mm,
And
right.
my opinion is you don't really. It's because most of the work is actually the work before that, the actual modeling, the actual thinking about it, and how would that look in the scaling. The other then working with a few terabytes in a student environment, that's very often you have exactly that problem, like you said, like you need to be careful of what you're doing, and so I tend to send them more into a route where they're small, interesting problems that are interesting if the scaling comes up, instead of actually downloading huge data sets and
Hmm.
pushing their AWS costs. Like
That's good of
in
you.
university, do they pay for that? No, right? That's the
No, they
university pays
don't.
for that.
Yeah, we tell
So
them, I mean, you have your free tier, they can probably do the entire class without spending $1 if they're
yeah,
reasonably careful.
yeah,
Yeah, that's interesting. Yeah, and I think that's a really good point, Andreas. The like for people who are learning data, I think there's this confusion where because I'm dealing with data science and data engineering,
Yeah.
I need to use very large data sets,
mm.
right? Because otherwise I'm just inferior as a human. Like, so like if it's not at least a few gigs or a few terabytes, like what's the point? But it's I think it's more understanding, okay, the underlying concepts of just basic best practices of columns and rows, for example, if that's the kind of data you're dealing with, like how do you think about these types of problems, right? Dealing with nulls, for example, big thing that comes up all the time. Dealing with just data quality issues in your tables, like how do you think about this? I mean, you could just as well use like a 20 row data set and I think show the same concepts. So it's interesting.
Yeah, that's it. That also, if you use a large data set, let's not look at the cost. The problem is very often like, okay, you run this, and then your jobs take some time to actually finish, and then they finish, and then the outcome is not the right thing, or something doesn't work, and then you start up again and again, and it takes a lot of time, and like, do you really need that?
Well, and the point is that these are principles that apply in production too. Like when I'm in development, I shouldn't be doing pipeline development on my whole data set. I mean, typically I can have like a 10 row, I can put like 10 or 20 edge cases into a table and test on that until I get my code right. And then I can gradually expand how much data I'm going to feed into this thing. Yeah.
Yeah, very good point, Matt. That's absolutely true. And then sometimes I feel a bit silly about when I do this. But it's, you start with something super small and you just try it out, like, okay, I know this is clean, so this should work. Then you build some errors or some problems in it. Okay, let's see if that works, and then you start scaling up and not like using the whole thing. Yeah.
I mean, it's a reality with data engineering. Like if you're processing logs, dealing with malformed logs is going to be most of the work, right? It's not the nice log entries that are easy to process. You have to identify those edge cases that are going to break your pipeline. And so practice, if you can pull out maybe 10 log entries that demonstrate these edge cases, that's probably going to be your development set.
Yeah.
Cool. I think we're almost at an hour, so
okay.
But it's been a fun conversation, and I'd like to chat more, obviously, in future times. So
I'm down for it. Just let me know. We're going to meet again.
Yeah, awesome.
Yeah, sounds great. And someday I want to get back to Germany. Who knows when that's going to happen? Have to say hi if I get there.
We'll see how long that takes until the traffic is normal.
Maybe like 10 years or something. Who knows?
Yeah.
Let's hope not.
Will they let in vaccinated Americans? That's the question.
Cool. I'm gonna hit stop record.
Stop the